Hello everyone, I'm Jen Wang from Arizona State University, study Computer Information Systems. In this video, I'll introduce my honor thesis of Darknet Markets Analysis and Business Intelligence. First, thank Dr. Victor Benjamin, Dr. Raghu Santanam, and Dr. Carlos Romina so much for all the supports and encouragements. So why am I interested in this topic? Because information technologies have already generated lots of data as so-called big data. And big data is not only growing fast in large volume, but also have types of structured data and unstructured data. Especially unstructured data requires special technologies for analysis. Because unstructured data is not well organized, which means cannot fit into database. There are different types of unstructured data such as photos, videos, and text. Big data accounts for about 80% of modern business data, which is a very large portion and is still increasing. But it's not very easy to deal with unstructured data and get useful information for business strategy. So I will introduce how to analyze darknet markets as a great example of analyzing commercial websites. Darknet markets are places where people trade illegal products such as drugs, credit card information. I selected RS Club Market from others as it's popular worldwide, so buyers and sellers may come from any country. Now, let's look at how unstructured data becomes structured and for analysis. As what you can see, you may think is a smooth progress, but it's actually not, especially at the beginning of the project. It was not an easy task for me to parse web data like this because many errors may occur. For example, the Unicode error. It occurs when computers decode text in different languages or there are some special characters that a computer cannot understand. And I was not really understand the difference between encode and decode, when to encode and when to decode. So that took a lot of time for me to solve the problem. And the web structure is not that easy for parsing as not all data points are in understandable text. For example, the feedback is not in the tag like feedback/feedback. It's in a table structure, so it's not easy for parsing. After all these problems are solved, it's quick to use regular expression in Python to parse all necessary data points such as listing titles, descriptions, and seller's information. In this project, I used .findAll as one of the regular expression methods in Python. It can search all the matching strings and parse the data. After all necessary data points are well parsed, it's necessary to clean them up. So it's important to separate long strings into arrays of words. This is one of the words list for a product. As you can see, there are still numbers and digits, which will impact the calculation of document similarities in future steps, so they need to be cleaned up. Next, after the digits are removed, you can still see the warning which shows that the text cannot be saved properly because some special characters. So it's necessary to remove them. Otherwise, they won't be able to save it as text files and analyzed in future steps. After all invalid signs are removed, it's time to remove all stop words. Stop words are meaningless words when comparing documents. The aids are all stop words. So after these words are removed, it's ready to implement doc2vec. Doc2vec is an advanced algorithm for calculating similarities of text. So it's a great tool for text classification. In detail, it creates vector for each word in a text file and returns similarities of these vectors. For example, the dot similarity method that I used calculates cosine value of document A and B. This is how to get similarity between two sellers using all their listing information in two different individual text files. As one part of the Python program, an Excel file with all results of similarities and seller levels are stored automatically. When we look at the results, we can trust their accuracy because the similarity of the same seller is exactly 1. In order to investigate the relation between sellers' similarities and their seller levels, it's necessary to collect scores of levels of all sellers. Taking seller Redson as an example, its level is 4.4106 as its highest one. Because the seller's level are always changing, so it's reasonable to keep the maximum. Based on all data collected, it's not hard to find that sellers who sell similar products have high similarity scores. For example, both of these two vendors sell digital products, so their similarity is pretty high. On the other hand, different types of sellers are far similar to each other. For instance, seller Danhash sells cigarettes, seller Oscar sells digital goods. They have negative similarity. Next, I select sellers who have similarity scores over 0.5. It's easy to find that sellers who have similar listings may not have similar reputations. For instance, vendor Credit Teller's seller level is 3.879. Vendor Fence is highly similar to it, but only has seller's level of 0.34. This conclusion can be affirmed with the correlation of sellers' similarities and their sellers' levels or reputations, which is about 0.005288. And this size of correlation can represent small or no relation in statistics. So I believe this project on darknet markets can be a great example of web data analysis, especially for unstructured data. Data users who are interested in this or similar markets can follow the project step by step. In particular, it's very helpful for undergrad students and entry-level business analysts when they have similar difficulties in their projects, so they can be more confident to embrace the era of big data. As for me, one of the takeaways is that I can understand and be more familiar with academic studies, from defining a research question to following instructions to complete it. But I also realize that I'm inexperienced in conducting research projects individually, because I have to recall some relevant knowledges such as basic statistics, which unfortunately slows down the progress. Another big challenge is there are many new technologies are involved in this project. They are necessary for analyzing unstructured data, but very new to me. I can still remember the first time when Victor asked me to write a parser using Python, and I couldn't even fully understand the syntax. But now I know not only how to parse websites, manipulate data in different types, but also use regular expression and get interest in natural language processing using Doc2Vec. The last part of challenges is about results. Is the result accurate? How do I know and how to interpret it? What I can learn from the number? Those questions are something that I never thought deeply before. But now, with Victor's help and studying related statistics, I'm confident that the conclusion is sound. In future, I hope to be more professional, especially academically. For instance, writing a better paper or report, being more prepared for projects, and scheduling things in advance so that I will have more room for flexibility and things that I'm not familiar with. Since sometimes people don't know what they don't know. Having a better plan so mentors or directors can be more comfortable with helping me. So thank you so much for your time, and please let me know if you have any question.